All right, so I'm going to talk about line segment dilations. And what is a dilation? Well, a dilation is a growth or a shrink. Right, we can go into talking about scale factors and stuff like that a little later, but I don't want to right now. Right now, we're just going to talk about growing and shrinking a line segment. Okay, so say if I have a horizontal line segment, we'll call that line segment AB. Okay, and this line segment, this one that I drew, has 2 units. So the length of AB equals 2. Okay, and it's dilated by a scale factor of 2, right? So scale factor is how much it's going to get bigger or smaller. And if the scale factor is greater than 1, it gets bigger, in this case longer. If the scale factor is less than 1, it shrinks. It gets smaller. Okay, so here I have, let's say that I have apply a scale factor of 2. Scale factor also is sometimes known as K. Scale factor, right? So that means I'm just going to double the length of this line. Okay, so the way I show that it underwent, this is called a transformation, right? Specifically a dilation. We're going to get into this a little bit later, but it's going to grow by 2. So it's initially 2 long, so now it's going to get, starting at the initial 2, that's a scale factor of 1, right? It's the same size, but then it doubles in length to 4. And we're going to call this B prime. I mean, it's after it grew, right? So A to B prime equals 4, right? So this is just a fancy way to say that I took this line and I doubled its length, or I stretched it, right? Now I can do that horizontally too. Excuse me, vertically. Let's say I have something like this, right? And this is AB, right? And AB has a length of 1, 2, 3, 4, 5, 6, 7. Okay, and let's say I apply a scale factor, also known as K, of, how about 1/7? Okay, so it's going to shrink to 1/7 of its original size, right? So I take 7 times 1/7, and I'm going to get 1, right? So then now the new unit is 1. This is B prime. Okay, so it shrank by 6/7 of its original size. It's now 1/7 of its original size. Okay, so now AB prime equals 1. All right, so I just multiply it. And now if you notice, all you do is multiply the original by the scale factor to get the final. It's pretty simple. Okay, but now say that I have a point here and a point here. There we go. And we'll call this AB. And we'll just say that AB, we'll just say that AB, for all intents and purposes here, is 10. Okay. Let's see, what else? I think I probably should expose you to Pythagorean's theorem now. So let's actually figure out how long this thing is. Okay, remember this length has 2 components. Okay, it has a left and right component, and it has an up and down component. So let's make a little triangle and see what the x component of this slant line is, right? Well, this x component is 1, 2, 3, 4. Okay, and the y and this component is also 4. Okay, so if I want to figure out the length of this slant, also known as the hypotenuse of this right triangle that I just made, I have to take that, square it, take that, square it, add them together, and then take the square root, right? So this is going to be the square root of 4 squared plus 4 squared, right? Which is 64 plus 64, which is 100 and, oh, sorry, that's not right. So this is the square root of 16 plus 16. So this is the square root of 32. Just some number. And if I want to break that down and to make it, this is some little algebra, right? If I want to figure out what that actually is, and some, the square root of 32 is not a perfect square. I could put it in a calculator and figure it out, or I could break it down and do from its factors. So 32, 8 times 4 is 32, right? So we got 8 times 4, and this 8 will break into a 4 times 4 times 4. Okay, so here I can, this is a square, so I can do square root of, this is 16 times 4, because 4 times 4 is 16. This here is my perfect square. All right, so I'll take that perfect square out, make it a 4, and I'm going to get 16 times 2, excuse me. Okay, so from here I'm going to get, because 8 breaks into 4 times 2. Okay, so here I'm going to get 4 square root of 2. Okay, so this ends up being 4 square root of 2, so a little bit longer. Square root of 2 is like 1.3 something, right? So it's a little bit longer than that, okay? So that is the length of this, of AB, right? If I want to dilate this, let's say I dilate it, and I want to dilate it by 2 or 3. I want to make this length 3 times bigger. Well, the way I'm going to dilate this is going to dilate both components of this. Okay, so if I want to dilate the x component of AB, right, it's going to be 8. So we're going to go from here. This is now going to be the new A, the new x component of A. So it's going to be 1, 2, 3, 4, 5, 6, 7, 8. Okay, and then I have to double my scale factor equals 2. I'm going to double the y component. The y component is going to be, it was 4, now it's going to be 8. So there's my 4. Go up 1, 2, 3, 4 more to 8. Okay, and then I'm going to go ahead and extend this line. B got extended because A was the center dilation, and there is now that length. So it should make sense that this is twice the length that it was originally. So this should be 2 times 4 square root of 2, which is 8 square root of 2. Now let's check it with Pythagoras. Well, I have a 4 square root of 2 plus a 4 square root of 2. That makes an 8 square root of 2, right? But let's check it with Pythagorean's theorem. Right, this was 4. This is 8, right, because it was 4 plus 4, so this is 8, right? So this is 8 squared. So the distance between A and B prime, right, is going to be AB prime equals the square root of 8 squared plus 8 squared, which equals square root of 64 plus 64, which equals the square root of 128. Right, and let's see, 128, if I can probably pull a 16 or a 64 out of there. That's 64 times 2, right, because I added 2 of them together. So that equals square root of 64 times 2, and lo and behold, this 8 comes out. From there, becomes 8 square root of 2, and that is the distance between A and B. Okay, so that's how you dilate a slanty line. with a little bit of Pythagorean's theorem to prove that it works. Okay, so you needed a couple algebraic skills in here. You needed Pythagorean's theorem, right? You needed to know how to simplify radicals, right, because of Pythagorean's theorem. So yeah, that's pretty cool. And you had to multiply. So a little bit of review of algebra, which is super helpful.